Hello everyone. In last video we discussed about basic of P&O algorithm, P&O MPPT algorithm. So today we are going to see about how to implement the P&O algorithm in MATLAB for solar PV system. So let we go for MATLAB implementation. So this is the overall Simulink model for that P&O MPPT algorithm for a solar PV system. Okay, so this is solar PV panel. So I'm going to take a 250 watts PV panel. Okay, in order to implement that system, so just you have to click this PV panel. So you will see the details about that PV panel. Okay, so the maximum power of that PV panel is around 250 watts, and then open circuit voltage is around 37.3, and the voltage at maximum power point is 30.7, and then short circuit current is 6.66, and then current at maximum power point is 8.15. Here I am going to use parallel and series strings R1. Okay, so I'm going to use only one panel for testing that P&O algorithm. So before going to test that P&O algorithm, so first of all we have to obtain that PV IV characteristics of that PV panel, the considered PV panel. So here we can see that we can obtain that IV PV characteristics of that considered PV panel. So here I am going to fix the temperature, because solar PV panel output depends upon two parameters. One is cell temperature and irradiation, solar radiation. So here I am going to fix that temperature, cell temperature is around 25 degrees Celsius. I am going to take a different irradiation. So for that different radiation I am going to plot IV PV characteristics of for that considered PV panel. So after fixing this parameter, just go to click this plot. So you will get another window, pop-up window. So this is the IV and PV characteristics, IV and PV characteristics of the considered solar PV panel. So this point, okay, the circle point is considered as the maximum point for different irradiation level. Okay, when the irradiation level 1000 watts per meter square, so we will get the maximum power of 250 watts. Okay, so just go to click this cursor, okay, and then check this one, click this one. Okay, so when irradiation 1000 watts per meter square, the power will be 250.2 watts, and then voltage of that PV panel is around 30.7 volt. Okay, when the irradiation is 800 watts per meter square, so the power is around 200 watts, and the voltage is around 30.68. when power that means irradiation is 600 watts per meter square, the power is around 150 watts, and then the voltage is around 30.62. when power that means irradiation is equal to 400 watts per meter square, then power is around 99.99 watts, and voltage is around 30.41. Okay, so this is the power level for different irradiation condition. Here we fix the temperature level at 25 degrees Celsius. So this is the PV and IV characteristics of the considered PV panel. Okay, so here we are going to use boost converter in between load and solar PV panel. Okay, so this one, so boost converter so is placed in between solar PV panel and load. Here I am going to consider different loads, okay, in order to check the reliability of that P&O algorithm. Okay, so this is a variable load. Here the load value I am going to take 5 ohms, and then 30 ohms and then 100 ohms. Okay, so these are the resistance value, load resistance value we are considering here. And then this is a P&O algorithm. So in order to execute the P&O algorithm, we need to measure voltage and current of the solar PV panel. So for that, just you go to measure that solar PV panel measurement, and then you go to use bus selector model. Okay, so this is a bus selector model. In bus selector model, we can choose different parameter of that solar PV panel. So solar PV panel has PV voltage, PV current, diode current, irradiation temperature. So here we need only two parameters. So one is voltage and current of the PV panel. Just you have to click select this one and select voltage and current of the PV panel. Okay, so after that voltage and current is given as input for that P&O algorithm, and then P&O algorithm going to be generate the duty cycle based upon that condition already we discussed in last video, right? So based upon power difference and voltage difference, it going to be generate the duty cycle. Okay, so the duty cycle going to be processed via PWM generator. Okay, so just you have to compare the duty cycle with the triangular wave. It going to be generate the switching pulse for that IGBT of that boost converter. Okay, so it going to be control that IGBT. So that means it going to be adjust the output voltage and current of the converter. So based upon that PV panel voltage and current, in order to extract the maximum power. So next you have to see about that program inside that P&O algorithm. After clicking that block, you will navigate to this editor window. Okay, so this is a program for that P&O algorithm. So in this program we can see that we have to measure voltage and current from that PV panel. So it will be input for that P&O algorithm, and you have to initialize some parameter. So the initial duty cycle for that P&O algorithm is considered as 0.42. The maximum duty cycle is considered as 0.8, and minimum duty cycle is considered 0.08. And then incrementing that duty cycle based upon that power difference and voltage difference condition. Okay, so that going to be considered as 0.00005. Okay, so these are the basic initialization in that P&O algorithm. Okay, and then we need to take some global variable. So here we have to take three global variable, nothing but V volt, P volt and T volt. Okay, so this is nothing but voltage, power and duty cycle of that previous instant. Okay, and then we have to check that previous voltage level. Okay, whether that previous voltage is having value or not. If suppose that previous voltage does not have any value, then we have to equate that previous voltage equal to 0 and previous power equal to 0, and then we have to consider a duty cycle, old duty cycle or previous duty cycle equal to initial duty cycle. Okay, so next we have to calculate that power based upon that data received from that PV panel. Okay, so the V and I going to be received from that PV panel measurement. So just you have to calculate that power equal to V into I, and then you have to calculate voltage difference, that means V minus V volt. So V is considered as a current instant voltage, and P is considered as a current instant power. Okay, so in order to take the difference, you have to subtract that current instant voltage with previous instant voltage and current instant power with previous instant power. Okay, so after calculating, after finding that power difference, voltage difference, so you have to implement that P&O algorithm. Just you have to compare that power difference whether it is less than or equal to 0 or not. If it is less than or equal to 0, then you have to implement this loop, right? Next you have to check the voltage difference, whether voltage difference is less than or equal to 0. If it is less than 0, then you have to decrement the duty cycle. If it is greater than 0, you have to increment the duty cycle. If the power difference is not less than 0, then so you have to execute this loop, okay, these conditions. That means if power level is not less than 0, okay, is greater than 0, then you have to check the voltage difference. If voltage difference is less than 0, then you have to increment that duty cycle, otherwise you have to decrement the duty cycle. So after finding that duty cycle based upon that power difference and voltage difference condition, so you have to compare with that maximum duty cycle and minimum duty cycle value, okay, whether the duty cycle from that P&O algorithm, whether is in between these two limit, right, minimum duty cycle limit and the maximum duty cycle limit, okay. If it is if suppose this duty cycle is greater than D max, then and the duty cycle is for example if condition, that means it should be that D should be in between this range, that means it should be in between D minimum to D max, okay. If suppose the duty cycle is more than D max or less than D minimum, then we need to equate that duty cycle with respect to previous duty cycle value. So D going to be considered D volt, okay. So this is a condition for checking that maximum and minimum limit of the duty cycle. So after checking that maximum minimum duty cycle, you have to store that current instant duty cycle voltage and power with the previous instant. So just you have to use this command in order to store the current instant to the old instant, okay. So this program going to be executed for every instant, okay. So based upon the previous and current instant, it going to be generated the duty cycle, okay. So that duty cycle going to be processed via preloop generator. It going to be generated the switching pulse for that IGBT. So this is the operation, that means MATLAB implementation of that P&O MPPT algorithm for solar PV system. Next we have to test the algorithm. So for that we have to do some testing, okay. So that means one is you have to test the system with the variable load, and then you have to test the system with the variable irradiation condition. So for that I am going to test the system with the variable load condition. So for that I am going to fix the irradiation, see that. So this input given for that solar PV panel in the MATLAB. So one is irradiation, another one is temperature, okay. So in order to test the system for variable load condition, here I am going to fix the irradiation temperature at constant level. So I am going to consider that irradiation is fixed at 1000 watts per meter square, and temperature is fixed at 25 degrees Celsius cell temperature. And then I am going to vary the load from 5 ohms to 30 ohms, and then 30 ohms to 100 ohms, okay. So for that I am going to create some logic, okay. From 0 to 0.1 the 5 ohms going to be connected with that system. After 0.3 second, so 0.3 to 0.6 second, the 30 ohms going to be connected with this system. After 0.6 second 100 ohms going to be connected with the system, okay. So I am going to load that system with a different resistance value, okay, 5 ohms, 30 ohms and 100 ohms, okay. So and then I am going to analyze the power extraction of that solar PV with respect to that P&O algorithm. So next I am going to simulate that model, okay. So you can see that this is power, okay. So here we are going to discuss about 3 parameters. One is power, voltage and current, okay. So power of the PV panel and power of that converter or load power. Next you have to discuss about the voltage of the PV panel and load voltage, and current of the PV panel and load current, okay. So you have to discuss this 3 parameter. already here we are fixing that irradiation temperatures around 1000 watts per meter square and temperatures around 25 degrees Celsius. That means solar panel the maximum power point is around 250 watts. Okay, so when you have to implement that P&O algorithm, you should extract that maximum power at 250 watts. So just I am going to simulate this Simulink model, and then you will get some results. Okay, so this is the PV power, so this is converter power, so this is PV voltage, so this is converter voltage, this is PV current, and this converter current. Okay, so you can see that. So already I told, right, 100 watt for 100 watts per meter square and 25 degrees Celsius, the power from that panel is, the maximum power point is 250 watts, correct? So after 0.3 second I am going to change the load. Okay, see that? Okay, after changing the load, the algorithm should be track the maximum power. Okay, so this is the load changing condition. That means the load going to be changed from 5 ohms to 30 ohms here. So from 0 to 0.3 seconds the load is is considered as 5 ohm. After 0.3 seconds is load is considered as 30 ohms. So you can see that the P&O can be extract the maximum power after 0.1 seconds. Okay, so after 0.6 second, at the instant of 0.6 I am going to change the load from 30 ohms to 100 ohms. So 0.3 to 0.6 load is connected is 30 ohms. So after 0.6 is load changed to 30 ohms to 100 ohms. See that the power extraction from the solar PV panel is around 250. So here also the P&O algorithm is extract the maximum power very effectively. So these are the parameter of the voltage and current. Okay, so you can see that converter voltage and current. Okay, when voltage going to be increases in the converter, the current level going to be decreases, like a transformer, DC transformer action. Okay, so in order to extract the maximum power from the solar PV panel. So this is a condition 1. So that means we are going to fix the input parameter. That means irradiation and the temperature fixed at a fixed point, and then we have to vary the load, and then we see about that variation of that power extraction. Okay, so next you have to fix the load. So I am going to fix the load at 30 ohms. Okay, I am going to fix the load at 30 ohms. So for that I am going to directly so I am going to include only 30 ohms resistance across that load. Okay, and then I am going to change that variation of irradiation at variation of irradiation for different step level. Okay, so that means I am going to vary the irradiation at 1000 watts per meter square, 800, 600 and 600. Okay, 600, okay, 400. Okay, so I am going to vary the irradiation 1000, 800, 600, 400 with the step of 0.2 seconds. Okay, and then so for that variation of irradiation, what about that the power extraction of that PV panel by using the P&O algorithm? Okay, we can see the detail. So I am going to simulate this Simulink model for this condition. Here the load is kept at constant, and input parameter, that means irradiation is variable. So every 0.2 second the irradiation going to be varying. Okay, so initially from 0 to 0.2 second the irradiation level is 1000 watts per meter square. So for that condition the maximum power is around 250. Okay, so it can be extracted from the PV panel because of that P&O algorithm. So after 0.2 second irradiation going to change to 800. So already in starting of that video we discussed about that IV PV characteristics. when the irradiation is around 800 watts per meter square, the power maximum power will be 200 watts. Okay, so that power also is extracted in the PV panel because of P&O algorithm. You can see that this one, after 0.4 seconds, the irradiation is going to be changed from 800 to 600. So for 600 watts per meter square with the 25 degrees Celsius, the maximum power is around 148.9. so that power also is extracted from the solar PV panel because of that MPPT algorithm, P&O MPPT algorithm. In 0.6 second, the irradiation change from 600 to 400. For 400 watts per meter square, the power levels around 98.9 watts. Okay, so that power also extracted from that PV panel because of that P&O algorithm. Okay, so you can see that variation of PV panel voltage and current. Okay, so this is PV panel voltage and current variation and with respect to the different irradiation condition. So this is the variation of that converter voltage and current for the different irradiation of the PV panel. Okay, so that's all about testing of P&O algorithm for a solar PV system. Next video we have to discuss about modified P&O MPPT algorithm for solar PV system. Okay, thank you.